So we begin VLANs. Quite a wonderful world of VLANs. When have you come across VLANs before, folks? Not long ago, last week. What did I talk to you? Remind me what I told you about VLANs. What comes into memory from VLANs? Anything you remember at all from any chapter ever? V does imply virtual. LAN, you should know already what that means by now. Yeah, nothing fancy there. So it's really, it's almost like we're making a virtual network, really, what we're doing. Rather than physically making a network out of cabling and stuff, we're making a virtual network. And the switches are able to do that. Switch can do this, and it also can separate out a network into sub-networks too. Without any complex, you obviously got to do addressing and stuff, but you can actually have a logically and physically separate network in different ways. So we're going to look at how virtual LANs are created and configured today. Here's your learning outcomes. Scans on these labs here. Lots of practicals actually. So we're going to explain how VLANs segment broadcast domains, implement VLANs to segment these networks, small to medium-sized business. The college here is actually a small to medium-sized business in terms of staffing, in terms of the number of people there. It's like got different departments, number of people in each department, and different networks for different reasons. And configuring routing between VLANs as well. So we've got the switch configuration and options around routing too there. There's a lot of practicals in 7, okay, and we're not going to be able to cover them all today. So this is why, Easter's, it's lucky that Easter will help you catch up on all these things. So I can have a good, solid knowledge on what VLANs are about. Okay, let's begin. Can I just do one thing actually, folks? I'm going to invite to people who are on the road. At least find out who we got on the road there. Okay, it's up here. I should pick up mine. I want to get one little link up on mine. Our Wi-Fi in. Now, WhatsApp Web is always a bit annoying within network here. WhatsApp Web is a really fun, useful tool. You just go web.whatsapp.com, and I can quickly go here and I can pay something as if it's on my phone. And there you go. Are they? Join. Done. Right, so here we go. Start off with LAN definitions. So VLANs can segment local area network devices regardless of physical location. Here's an example. In this particular situation here, it's a really messed up organization actually. Like, why would you do this in any place here? Why would you have like one IT person on every, maybe there's a reason, but one IT person on every floor, one HR person on every floor, and a salesperson on every single floor? Yeah. And so they're basically like in every level of floor, you've got the whole organization in some way, people are represented. Probably, yeah. We need to get some people to sort this out. It's a mess. Anyway, so the problem is, given the physical devices have actually got a switch on every single one of these. You've got a switch, switch, and these are connecting these 3 devices together. But these teams need to be able to share stuff. What are we going to do? How are we going to sort that problem out? So what VLANs do, they create a logical partition. Logical means like it's just literally created in a virtual way, not physically. And we're able to partition the network so that we can create multiple joint segments across the existing network. Now, usually the way we can do this is we can create a switch configuration. Each one of these things is called a VLAN. VLAN 2 is the whole IT team. Even though they're on different PCs and on different switches, doesn't matter. You still can configure beyond that. You see how useful this is a skill to have. Similarly, VLAN 3 is HR, VLAN 4 is sales. And these are all what we call broadcast domains. I can make this box here. Remember the idea of a broadcast domain? What's a broadcast domain? I'm sending out to everybody a message, okay? And it can be sharing files and whatever else you've got in the same. One to all, yeah, correct. So each VLAN it creates a broadcast domain that can span across multiple physical local area network segments, okay? The hosts on that VLAN are not aware of the VLAN's existence, don't really notice it. There's nothing done, it's all configured in the switch. Another key thing is they're mutually isolated and packets can only pass between VLANs via a router. So a router is crucial aspects of this too, okay? And things can only go from IT to HR, not via the switches. If you want to get from there to there, right? It's at this level you can do that. Okay, only that can control you going into these different spaces from here to here.
Will that cause more problems?
What is that, Stuart?
Oh, well, I don't know.
Go on, yep.
You have to go from there to there, and then you're saying come back all from the switch, right, and then you have to wait back.
I mean, across a distance span, right?
Yeah. Well,
it's more about how broadcast domains are managed, you know. You don't want to keep the broadcast, you want to make too much congestion. The way to make it efficient is not to have any congestion at all. These guys are generally only communicating with each other. If, however, IT needs to give HR a message or send something to them, or have a shared folder, you know, like a shared resources folder, then the way that's managed best is for the traffic to come by the router to manage that stuff. Yeah, traffic. So something could come in from even outside wanting to go to one of these places. They're just best kept as separate broadcast domains. The smaller and more efficient a broadcast domain is, remember, the more you've got it tightly on what you actually need it for, the more efficient and fast the network is. Yeah, it does make actually quite a noticeable difference in productivity. If you work in any office situation, you know people are always moaning about the network, or logging in, or doing anything. You know, it's just always about how quick something is. So when it gets like noticeably slower, it does create irritation and productivity problems. Okay, so here's an example of the benefits of VLANs and why we do it. So we've got better security with different VLANs. Here's an example where I've got a faculty VLAN. That's my staff, right? And I've got you guys as students. But also we have guests, people who hire rooms in the college who use a guest network. They might want to share stuff too, but they don't want to be mucking around with our stuff and nor with your stuff. Yeah, we have a separate domain for them. So that's really why this has been split this way. Improve security, reduce cost, it's cheaper. Then, you know, if you have what's more expensive is to move people around. No one likes to move desks. There's a whole other office politics situation. The moving desks issue, right? That one, you've all heard of it, right? As an example. Oh, he's the guy, yeah, chair breaker. And then you've also got things like the issue of cabling and like physically cabling something from wall to wall and what's involved with that. Improve security because you've got a tight domain, you've got better performance, smaller IT efficiency, management becomes so much easier. You can set the same policies of access and restrictions on similar broadcast domains, e.g. IT team always has access to everything, right, always. The HR team gets access also to everything. Sales get access to nothing, right? It's that kind of a thing. So whatever you follow through. 17 right here, default VLAN. Now, common types of VLAN. You all know there's a default VLAN. The first thing you configure on a switch often is the default VLAN. And that VLAN is often VLAN 1. Okay, that's the default. All switch port members are VLAN 1 by default. So if you don't configure a switch at all, you start with VLAN 1, and everyone has that. You can see here, there's a little picture. VLAN 1, active. All ports assigned to VLAN 1. Okay, that's our starting point. So, other types of VLANs we have are data VLANs, so for specific groups of users or devices. They carry traffic from the users. Native VLAN carries all untagged traffic. Traffic does not come from a VLAN port, and it's VLAN 1 by default. And finally, management VLAN, which is the one you might have configured, carries network management traffic, including a few other bits and pieces of abbreviation, which I'll talk about now. And this is the default VLAN is used for network management. Okay, you're not on VLAN 1 to begin with. That's why you have to start configuring the switch to separate this stuff up. Now, SSH we've heard of. SNMP is a type of protocol, and syslog, we discussed last week, is actually a reporting mechanism. As network managers, you configure slog and syslog, and it sends you like reports of what's going wrong, faults, infringements, broadcast collisions. You can make it send things through to you. All right. Now, voice VLANs. As you know, in this building or in this room here, and all classrooms in the college, we have Cisco IP phones. They will carry voice traffic, and the voice VLAN is used for that. So those clever switches that can carry voice, particularly the 3000 series, they will give you the ability to have like phones powered over Ethernet and literally split one single expensive BT phone line into many sublines with extension numbers on them. So, what you need to have to support the voice VLAN is assured bandwidth, less than 150 millisecond delay, so your voice quality is in real time, like an international phone call, right? So you've got no lag. Transmission priority over other types of network traffic, and the ability to route around congestion. Here's an example here to show you what's happening. This switch is configured to support voice traffic. VLAN 150 is for voice VLAN alone, and it prioritizes all traffic for voice to subsequent devices. Here's the little IP phone there. This switch port F18 has got the voice traffic configured. Okay, and this port sends frames to provide information used by the phone, and forwards frames associated to VLAN 150. Okay, good. So you must configure a particular port to carry voice as well. Now here's the first one. There's two packet tracer activities there. I'm going to move to the second one actually. This one is more of a kind of like something you're going to be all right with, but you probably should do outside of a lesson. It's not too complex. Just really talking about who's hearing the broadcast going out from this particular switch, right? Who's hearing that? Where's it going to? I think you'll be all right with that one. LAN trunks. Now, a trunk is not only an elephant's thing, right? It's also a point-to-point link that can carry more than one VLAN on it. Imagine it like being, it's like a big virtual pipe, really, yeah, where you can put things down it, and more than one VLAN, okay, can be carried through it. So what happens is you trunk together devices, which is almost like joining them together in a way, so that they can carry, so the switches between themselves can support communication between different VLANs. Okay. So a little example here, this VLAN, this switch here, has been configured to support VLAN 10, 20, 30, and 99, 10, 20, 30, 30, 20, 10, and 99, which is your management. And that's been done on a trunk configuration. And these are the various different network addresses for those things. FO1 to 5 are trunk interfaces with native VLANs. Might make no sense whatsoever right now, okay? So just bear with it. But ports 1 to 5, let's find them 1 over here, up to 5, not even showing any more than that, are with that native VLAN there. 11 to 17, VLAN 10. 18 to 24, there's 18 there. VLAN 20, VLAN 20, there's 11 again there. And 6 to 10, VLAN 30, this one and this one. The protocol, by the way, for information, is IEEE 8021Q, is a trunk protocol. I do believe actually that's used in one of the Cisco configuration commands that will come up later. Okay, now controlling broadcast domains with VLANs. So, okay, if the switch port gets the broadcast frame in, bit like what we've seen before as example. If it receives a broadcast frame, it forwards out to all ports except the originating port. Okay? And the entire network gets that broadcast because it's one domain of network. You can use VLANs to limit how far broadcast frames will go, because each VLAN is a broadcast domain in itself. And they help to control the reach of the broadcast frames and their impact. In this example here, VLAN 10 is sending a broadcast frame. Okay. Trunk links between S1 and S2 and S1 and S3 propagate the broadcast from VLAN 10, okay, to other devices in VLAN 10. So I've got to start from here. I've got to reach this VLAN over here. Okay. So our configuration of the trunk in here allows the interchange through these different devices. Only devices in the same VLAN receive the broadcast, so only this PC4 will get what PC1 is sending out. Everything else is not really aware of it. Now, remember, how on earth, what's actually happening here? What's going on behind the scenes? If you remember, like every kind of, on the OSI layer or TCP/IP protocol, we have the ability to, on frames, put things into frames that create a kind of a checksum. You can check for errors, we carry data, we can put the source destination address, the IP and the MAC, all that stuff goes on for those frames, okay? At Ethernet level, IP is obviously not a part of that, that's a layer above, but it's all about MAC addresses. At Ethernet level, this is a layer above physical, right? The actual physical zeros and ones. So therefore, when the frame being sent across, we can not only include the data destination source and MAC source, but have a look at this, so you can visually remember it this way. You can see we only also have is, you've got that usual stuff, you've got this stuff here, you've got your checksum there, you've got the tag, okay? So this tag opens up to these four different elements, which allow us to identify which VLAN the traffic is for. That's really how this is working. So before a frame is forwarded across a trunk link, it must be tagged with the VLAN information. Okay, we put a header in the frame, and that allows us to send multiple things through a trunk link. This could be for VLAN 10, goes in that direction, 20, 30, etc. This VID is the VLAN ID there at the very end there. This VID there. So we know about this protocol. Switches are the very devices that add the VLAN tagging information after the source MAC address field. That's what they're doing. They grab the frame, go and insert this VID into it, okay? And that contains the other objects too. And then trunk links add this tag information before sending the frame, and then remove the tags before forwarding the frames through non-trunk ports. So if we're going to a non-trunk port that's not connected, it takes the tags off. If it needs to go somewhere else, yeah. Okay, tagging. So control traffic on native VLAN should not be tagged. Okay, this is your management tagging, a management line. Frames received untagged remain untagged and are placed in the native VLAN when forwarded. Okay, so we keep it all untagged there. If there are no ports associated to native VLAN and no other trunk links, we drop the untagged frame. When configuring the switch port on a switch, configure devices so they don't send tagged frames on the native VLAN. Okay, so no tagging in that route. And the native VLAN is VLAN 1 by default. We've heard that like 10 times now. Okay, now voice VLAN tagging is again very similar. We have to configure the IP phone, so that the port that's talking to the phone. And right in my classroom here, it's going into the ground. That's the port I'm referring to. That then goes to a switch, actually not in this back of this room here, but the one next to it. We use the VLAN for voice traffic and for data traffic from a device attached to the phone. They're both separate things. This link between the switch and the IP phone behaves like a trunk to carry traffic from both VLANs. Here's an example of this being configured. That's been updated since last year, actually. It's nice to see this. There's a configuration of the switch port. Make it a bit bigger for you. It's been instructed for VLAN 150, prioritize voice, forwarding to VLAN 20. Okay, it goes to the switch. There's your phone. That's been configured to allow the voice VLAN traffic. So it's taking it in, yeah, and can pass things on that way. These IP phones have integrated 3-port switches. I'm thinking about actually taking mine apart here or looking at it. All I can see is Nicholas can probably see it. What? Oh, sorry. That's a little trick I can do. Let's try a little trick out, shall we? Why not, eh? Oh, it's so dark. Oh, hello. That's my flask. Okay, now I think in a bit of light here, I'll show you kind of what lighting and what I'm up to, but the IP phone, it's the light. Oh, yeah, give us some light, please, Stuart. Old lighting technician over there. Is that any better? Yeah, you got that? I've got so much going on in maths just to find this out. This is ridiculous. I'm sure I can do this. It can be done. Can do that. That's close enough. So I've got here. There's my kind of like protocol, and 7941 series says over here. And we've all got extension numbers at the college, and every classroom now has this. We never had this before. We had like IT support problems in classrooms. And, yeah, come over if you want. I don't mind. Teachers used to have problems, right, with that because they had to go downstairs to call IT, and they couldn't leave. And you can't leave the classroom either. So what are you supposed to do? They'd use their mobile phones, and they weren't happy with that. How this thing looks from behind it. Take it off. Not a break the thing. Underneath it, you've got a line. There's your like normal phone line there. It goes into the ground, and you've got your Ethernet, which is also giving it power. There's no other power supply in this thing at all. Yeah. All you have is an aux for config. If I unplug it, it'll cause problems. And you have these Ethernet. Yeah, 10 to 100. That's a carrier speed on this thing. Yeah, 10 to 100. PC.
Category 6.
Yeah, Cat 6 cable. Carrying at fairly good speed. And in the future, who knows, might even be a video phone. You can do headphones on this thing as well. So you've got a phone line thing on it. And that's actually for only connecting the headpiece. Just so if you want to get a headset, that phone cable is actually for this. Yeah, exactly. And see these things here, these are just in case you want to have a headset. Pull this out and put a headset on. Call center style. Okay, so that's it. Video demonstration of an IV phone. There's 3 ports in there. The front one should come off if you can do. Okay. So we've got here these various ports. You can connect to other devices, other voice over IP devices. There's a 1001 interface that you saw. Carries the IP phone traffic, and the port 3 is an access port 2, so aux port, next to a PC or other device. You can get various applications like that can talk to the phone, you know, like PC based. I know some charities run like some software on their through here, the desktop, that talks to the phone and picks up all the voice, and you manage your stuff from your PC rather than muck about with the phone. It's going much more that way, I think. People pressing the messages and voicemail, I have it all digitally here, so you can pick up audio files that are actually data files, and you can forward things around, much more efficient. That's how it's going to go totally, I think, in the next few years. It's very inefficient to have multiple phone lines in one business. Okay, now here's a little packet tracer for you. We're going to look at a VLAN implementation and see how it's set up. Let's just talk about what that is. 6127 and what's involved in it. Let's go there. Go to Gradebook. I'm going to get back into my materials for a second. Six, 2, 1, 7. There you go. We're going to learn creating and naming VLANs and assigning ports to specific VLANs. Configuring VLAN instructions, and there's your PKA file. Let's open this up. Addressing table is already provided for you. You just need to look around this topology and see how this is all set up. Works with the VLANs. What you're going to be doing is, first of all, look at them. Issue a command that displays all VLANs configured. verify connectivity for PC pinging, configuring VLANs. Hey, well, am I the right one? Does it even cover that? Someone's on the right, folks. Hang on a minute, I'm on the wrong one, I think. Someone help me. 6127, oh my God. Sorry about that. What am I doing? You've not even done that configuration yet. You have to investigate one first. So investigating is, that's the right one, 6127, I beg your pardon. This one here gives you a full kind of even more complex topology here. Dressing table. It's going to observe how the things move around it. Okay. You know what? I personally think, if you agree with me, that this is not a great one to be doing. I'd rather you do the configuration, actually, spend more time on that. Would you agree on that?
I think I do fine with them. I don't mind doing them, but sometimes if you can't get them finished. I mean, I saved one last week.
Yeah.
But when you open it back up, anything you put into it, you don't know where you are.
I know. The thing is with this one, when it's an observation, you can do it anyway, just you observing how
I had a look through this week's ones. There's a lot of packet places this week, isn't there?
There is a lot, yeah. I think this one would be better one to do. Personally, this is a much better one to do. Hands-on still. Config a VLAN much better. So I'll keep, yeah. But I've got to first go through the teaching of it first. I'm going to go through the kind of how you config, which I realise I haven't done yet. So let me do the config, how you do it, and then let's configure a VLAN, yeah? Much more useful skill to have. That other one you can do in your own time. Is that okay, folks? You all right with that? Yeah? Then we've got any hesitation on that, because it's the best thing to do with the time we have. Okay, so how we implement a VLAN now. That's more important, isn't it? So catalyst switches, that thing that Hermione brought in the other way today was actually a 3560 series. Hopefully he's at home watching Zoom, I don't know. But that's what he had. That can support over 4,000 virtual VLANs. So
worth buying something like that, really.
it is. Well, it is. I think for learning switches, better to get one of those.
Yeah, because you look at eBay, there's all types of price.
It's right on 3,000. You can get a good deal on it. And it's much better to have it. If you're doing Cisco Serious Learning the course and wanting to go further, if you've got a 3,000, you can do all the stuff you need to do.
I'm assuming there must be stuff on YouTube of people showing stuff.
Yeah, loads of stuff. It's best to get something that's well known too. 3560 is quite well known. Yep. Right. So normal range VLANs, numbers from 1 to 1005. Store the config in VLAN.dat. You might have seen this file before, right? Remember in Cisco tests, the first one you had? There's a little command about that in the skills test, remember that? IDs are reserved from 102 to 1005 for other things, okay? So I will leave those ones alone. You can do an extended range from 1006 to 4096. Config stored in running config, okay? The VLAN trunking protocol does not learn these extended ones. It's only for these, yeah, 1 to 1002, and leave the rest. How you create a VLAN? Here we go. Oh, Ruby's not here now. Just going to pick this up. So creating a VLAN, entering the global config mode, conf T. I'm on the switch right now, okay? And I create a VLAN with a valid ID number. VLAN ID. This one example is given the VLAN 20. I then give a name for the VLAN. It's helpful having a name for it. It's logical. I'm calling it student. This name is, I'm writing name student and then doing end. That's me creating my VLAN. Assigning ports to VLAN. So once your VLAN is set up, what are the ports you're going to configure for it? You again enter on the switch the global configuration mode. Then enter the interface configuration mode. That's how we sort the ports out. Interface ID. The port must be on access mode, switch port mode access. Assign the port to a VLAN, switch port access VLAN, and that's the ID I want to assign the port, link it to. Okay? Earlier on it mentioned, let's give a couple of examples, right? I think I mentioned 20, but let's look at the examples given here. And then you go to end to return to privileged exec mode. So don't forget that end at the end of it all. This sort of thing would go in your engineering journal with these kind of commands to memorize and learn them. Here's some examples of switches configured. So here we go, we're configuring this switch here. Interface 18 for port 18 has been configured to give access to VLAN 20. So we are doing interface FO18, switch port mode access, switch port access VLAN 20, and end. That example there on S1. Let's go over here. Example 2, S3, VLAN 20. We're giving it name, student. Also giving another VLAN 150, which is the voice VLAN, that phone there, exit. Now just for the FO18, I want to configure that particular one. It's quite a good example, this actually. This particular one, this FA018, I'll recap this. For me, what you've got to do is you've got to look at slide, the section before this also. We're now talking about how we configure VLANs, the important bit, which sadly you left. So you look at these bits here. I'll quickly click over them, right? So that's how you configure a VLAN. Configure terminal, ID, name VLAN, and that's how you name it, identify it. Okay, and that's right. You give it a name, like sensible name, like student. It's actually the network name, right? It's a VLAN. It's a whole broadcast domain. We're going to call it student, and we're going to end there. Right. That's how I do the actual VLAN setup. Then I need to do this thing where I have to assign a port to the VLAN 2. Okay, and port assignment, I'll use a bottom right example next time, is config terminal, interface ID, FO, whatever it is, switch port mode access, switch port access VLAN, VLAN ID goes there, and then end. Here's an example. So I'm first naming my VLAN. Here, VLAN 20, name student, 150 is voice, exit, come out. I'm in S3 all this time. Interface 18, switch port mode access, and I'm configuring the ports as well. The port has got to be able to get to
that one there is split out with voice.
Indeed. Yeah, so what we're doing is we're actually making this interface, FA18, carry, right, both traffic for both networks down one port. And we're sharing the port in a way.
Traffic and voice.
Traffic and traffic, which is both voice and data. Yeah. So switch port mode access VLAN 20 is granted, and then we've got this thing on voice there. This is a voice configuration command, folks. If you don't know this one stuff, there's QoS is a kind of prioritization of voice. Switch port voice VLAN 150. So this thing also can be utilized. Receive and send. Okay. That's how you assign the port. Next thing is changing port membership. How do you remove a VLAN assignment? All you do, say I want to turn FO18 off and remove that entirely, configure terminal, interface FO18, and I do no switch port access VLAN. That will deactivate that port, okay? And here's an example here. You can see FO18 down here is now returned back to the pool of VLAN 1. Was previously on, if it was a VLAN 20, it would be down here. So let's just scroll down on this. Oh. See 20 there, student? That's the VLAN 20 there. It will be, port 18 was previously assigned there, has shifted up to this lot again, back to the pool. Okay, other thing about configuration. How do I delete a VLAN? Use the no VLAN ID global config mode to remove VLAN. So here's an example here. I'm doing a conf t no VLAN 20 end. I've deleted VLAN. And you can do sh VLAN brief to show you all the configuration commands. It's referring to that actually in a minute, isn't it? Yeah, sh VLAN brief. Okay, is what's being used here. To delete the entire VLAN DAT file, use the delete flash :VLAN.dat privileged exec mode command. That's all the VLANs to be removed. And you can use this if the file has not been moved from its default location. That's usually where it hangs about, right? Okay, how you verify VLAN information, you've got two commands. Show VLAN name student. That's actually showing you the student one. Whatever name you put there will show that VLAN. Okay, and there's your kind of result there. Comes back with that. And you've got show VLAN summary. which shows you how many VLANs you have. You also have, looking in more detail, the interface. Show interface is VLAN 20, shows you that if it's up or not, and information about its the kind of various stats around the using of this particular virtual network. This is the right one, I think, now. We're there. Right, okay. So 6217 is the one we're going to do. Now we're going to configure the VLAN. Let's look at it again. There we go. And I'll get it printed out for you in a minute. So what you're going to do is you're going to display your current VLANs, show them the commands you just saw now. Okay. Verify connectivity by pinging. Things are going to fail here first, right? Then you're going to sort it out, go in there like on the mission, create a name VLANs on S1. You're going to make the following VLANs. You're going to verify the VLAN configuration, create VLANs on S2 and S3, verify, assign VLANs to ports on S2, assign ports on S3, assign voice on S3 as well. And I'll show you a little problem here that you come across. Okay, also here. So good luck with you on that, folks. To begin, I think if you're going to work quite quickly, you might get in before the break of 7-ish, right, or 7:40 or so. Yeah. So I'm going to print this out for you all now. How many have I got here today? 6. Let's take some questions while I'm getting this going. 6 print. Okay. Right, any questions on this, folks? Ready to go for it? So if you can just go through the NetAcad and go through that while I get your hard copies, download the PK file and you move again.